Hello all, we're going to continue working about functions and graphing and all that stuff, and we're going to dig into some more stuff regarding functions because of how they're written and what's called function notation. And so we're going to dig into that with these two questions here. The first is we're going to be able to tell whether or not an equation is a function, and it comes with practice. I mean, I already know the answer by looking at it, but that's me. With practice, you'll be able to do the same thing as well. The second one, problem number 2, will go into how to read function notation and how to work with it and what it means. So we're going to dive right in. The previous video about domain range and functions should be helpful with what is a function, and we'll be able to rehash that definition through working out this problem here, question number 1. We're going to prove whether or not any equation is a function. And quite honestly, the best way to do that is very simple. Graph it. Whenever you're dealing with something, if you can't tell, like I already know the answer to this, if you can't tell whether or not it's a function, we're just going to graph it. Besides, if I put the if I put the word prove there, you're going to have to show me. And so there's one of two different ways, and I'll talk about that in a second. So to tell whether or not something is a function, we can simply graph it. And in order to graph it, we're going to make a table of values. And this is going to be kind of interesting, because I'm going to teach you a couple things here. All right, so we have our table of values. And just like normal, we're going to pick our values for x. We're going to use a good old, 2 positive values, 2 negative values, and 0, and see what happens, right? So we have, -2, -1, 0, 1, and 2. And we're going to see what we get for y if that's the case. This is gonna bring in a whole lot of math. So I'm actually going to use this space here instead of working to the side. So the first x value we're going to use is -2. Okay, so how does that work? Well, we're going to substitute just like normal. So we would have -2 is what is equal to y squared, and then we're going to solve for y, right? And so how do you solve for y? We've got y squared. And you got to remember how to undo y to the second power. The way we undo y squared is through taking the square root. Okay, so we undo y squared by taking the square root of y squared. Okay, and then that will then the square root of y squared gives us y. Okay, so we have to remember that. So how do we work with this situation? Well, we have -2 is equal to y squared, and the work we have to do is take the square root of both sides. So when we take the square root of both sides, we have our y is finally isolated. The square root of y squared is y, right? So this is what happens on the right-hand side. Well, what's going to happen on the left-hand side? We get the square root of -2. You try putting that into your calculator, you're going to get an error message. That is undefined. Okay, it doesn't exist in the real world. It exists in the imaginary world. We'll get there. So if I plug in -2 for x, I have an undefined value for y. Isn't that weird? That's totally weird. So what's going to happen with -1? So we're going to do the same thing. Okay, so we have -1 is equal to y squared. And again, we're going to undo that by taking the square root of both sides. Okay, so now what we're going to do is take the square root of both sides. And now our y is by itself, because you got to remember, the square root of y squared is equal to y. And then what's the square root of -1? Again, undefined. It's actually an imaginary number called I, but again, we'll get into that later. So that's undefined. So what's happening here? Some weird stuff. Okay, so now let's continue. Now we're going to take this, plug in 0 for x. This is something more doable. So if we have 0 for x, that's going to equal y squared. And then we can take the square root of both sides. And it turns out that y is equal to, and guess what? We can take the square root of 0. The square root of 0 is 0. So if we plug in 0 for x, we get 0 for y. That's helpful because check this out. Some cool stuff is about to occur. What if x is 1? All right, so if x is 1, plug that in. That's going to equal y squared. And now we're going to take the square root of both sides. And the square root of y squared is what gives us y. And now what's the square root of 1? Well, the square root of 1 you might think is 1. And I totally agree with you. That is completely correct. The square root of 1 is 1. All right, so we'll get back to that later. For right now, we're going to say that the square root of 1 is 1. And then we're going to do the same thing with 2. All right, so now we're going to plug in 2 for x and see what happens. So we plug in 2 for x, and that's going to equal y squared. And then we take the square root of both sides, and then we have y equal to, well, the square root of 2. What is that all about? The square root of 2? Okay, so we'll put that in there. So we plug in 2 for x, we get the square root of 2 for y. Now remember, we want 5 ordered pairs, right? So if we look at what we have so far, we only have 3 ordered pairs because the first 2 are undefined. And now we're also noticing with this last one, 2 square root of 2, maybe I should pick an x value that's going to be better. So I'm going to pick 2 more values for x. Okay, so let's pick 2 more. If I pick 2 more values for x, I can pick 3, right? I could totally pick 3, but that's not a good thing because we're going to end up taking the square root of it. So how about I pick 4? Okay, so now this one I'll plug into the side. If I have 4 equal to y squared, and I take the square root of both sides, that means I'll have y equaling to the square root of 4. And the square root of 4 is 2. Yes? Yes. Is there anything else? We'll get to that in a second. So we can have 4, 2, and then of course let's do a 9, 3. Okay. Now what we're going to do is sketch this graph. Okay, so we'll sketch this graph and see what happens. Hopefully you'll find something strange will occur. And if you saw the guaranteed pass notes, you might know a little bit about this equation, but let's take a look at what's going on here. So we have a point, now remember, -2, -1, those are both undefined. So x can't be out here, right? There is no graph out here. But we start our graph at 0, 0, and then we have a 1, 1, and then we have 2 square root of 2, I don't know where that is, but we have 4, 2, all right? So guess what? The square root of 2 is like around here, isn't it? It's like 1 point, well, it's actually 1.414. Anyway, another 1. So then we have, 9, 3. So we can tell that this graph looks something like this, right? And it's going to be a little bit curvy. And that's what that graph looks like. And so far, this looks like a function, right? Well, now we got to do some thinking. Because there's something kind of strange about the square root of 1 and the square root of 4. There's something strange about the square root of 1 and the square root of 4. So the square root of 1 we said was 1, and the square root of 4 we said was 2, right? Okay, so we have that. Let's hit pause for a second, and let's wonder if there is a different way to approach this problem. Okay, so let's hit pause here, and let's try this a different way. So remember, we had our original equation, and it's still the same, right? What if we had x equals y squared? It's the same equation. Oops, wrong thing. There we go. So we have x equals y squared. Now we're going to make a table of values again. But this time, what if we picked, since x is by itself, what if we picked our values for y? Can we do that? Yeah, we can. So what if we pick values for y? I wonder if anything interesting will occur. Okay, so let's do, what if? What if? If we pick values for y, will something interesting occur? Let's find out. Okay, so now we're going to substitute our values for y. Is that legal? Can we do that? Sure, why not? We can do that. If we pick our values for y, look what's going to happen. We would see that if we have -2 for y, guess what -2 squared is? It's going to be +4. So x would then equal +4. Isn't that neat? And then we can put in -1 for y. Is that legal? Totally legal. All right, there's nothing illegal about what we're doing. And if we plug in -1 for y, I guess we're going to have for x +1. And then we'll have 0. Now what's going to happen if we plug in 1 for y? Do you think anything weird is going to occur? So if we plug in 1 for y, guess what we get for x? If we plug in 1 for y, we get 1 for x as well. At this point, when you look at the xy table, something interesting should be going off in your head. Okay, but we'll get to that in a second. We'll do the last one. What if y was 2? What would our x value be? If our y was 2, our x value is going to be 4. Is this legal? Well, yes, it is. All right, now, remember what the original question was. What's the original question? We are proving whether or not the equation is a function. And the first time we did it, right, we picked our values for x, and so far it looked like a function. Right? We picked values for x, and it looked like a function. All because of this strange thing happening here. The square root of 1 being 1, the square root of 4 being 2. And so far it did. But if we do it a different way, something weird is going on. And I'm all about that stuff because that's what makes this fun. So let's graph what we have. Hopefully right now you can see that this particular set of values is not a function. Right? Because from the previous video, we know that we have to have only one output for each input. Okay? Only one y for each x. But that's not the case going on here. Right? We have a point at 4, negative 2. 2, 3, 4, negative 2. We got a point here. We got a point at 1, negative 1. We got a point at 0, 0, 1, 1, and 4, 2. What's happening with this graph? Now, if you can see what's happening with this graph, we had what we had before. Okay, so you remember this top part is what we had already thought we had before. But then also, we're discovering, you know what? If I have x is 1, I get a couple of outcomes. If my x is 1, my y is negative 1. My y is also positive 1. What? Isn't that weird? So if we go back to our original thing, we thought this might have been a function, but because when we put in 1 for x, and we put in 4 for y, or 4 for x, and we put in 9 for x, we have to know some things about the square root. Okay, so the square root asks a question. Okay, the square root asks, what times itself gives you what's inside? Okay, that's what the square root symbol is asking. What number times itself gives you what's inside here? So this question is asking, when we take the square root of 1, we're asking what times itself gives us 1? And of course the answer is 1. 1 times 1 is 1. I totally agree with you. But is there anything else? Right? Is there any other number that we can multiply by itself that would give us positive 1? And the answer is yes. Yes, there is. Negative 1, right? Negative 1 multiplied by itself. Negative 1 times itself is positive 1. So the square root of 1, it could be 1 or it could be negative 1. So when we're making our table, we forgot to say that if x is 1, y could be 1. Y could also be negative 1. And if x is 2, y could be the square root of 2. It could also be negative square root of 2. It could also be negative 2 here. It could be negative 3 here. So what does that mean for our original graph? It means that, well, if we have x is 1, y is 1, y is also negative 1. 4, 2, 4, negative 2. It means the graph is going like this as well. Now we can clearly see this is not a function. Okay, this is totally not a function. Not only does it fail the vertical line test, okay, fail the vertical line test, because you can see any vertical line is going to cross more than once. Boop, boop. That's a fail of the vertical line test. We can also look at the ordered pairs. Okay, the ordered pairs, we could have 1, 1. We could also have 1, negative 1. So that when we're looking for whether or not something is a function, we can look at it that way. And that's giving proof that this equation is not a function. Okay, this equation is not a function. So we have to be careful when we're working with the square root. Okay, so the takeaway here is the final note. The square root of 1 is either 1 or negative 1. And if we know that, then we can easily see that this is not going to be a function. So not a function. And there's the proof. We have to be careful with that stuff there because it's some fun math. All right, so some fun math going on, and you'll eventually learn that that you can tell by looking at it whether or not it's a function. That comes with practice and experience. And then later on in the year, we get to play around with this picture, and we'll talk about that later. On to number 2. Okay, so if you had any question on that one, there we go. We proved whether or not the equation is a function. We proved that it wasn't a function, not a function, because of either the graph or a handful of ordered pairs where you would see a repeat in the x value, okay, repeat in the domain. So what about this next one? If we have f of x equals that and g of x equals this, find g of 5 and f of negative 3. Well, first of all, we got to read this stuff right. If we have f of x, make sure you know how to read that. It's pronounced f of x. This is not, and a warning here, this is not multiplication. This is function notation. This is not multiplication. It is function notation. So make sure you can recognize the difference. We aren't multiplying f times x. This is f of x. Okay, when I ask a question like what I'll ask in a second, that question, this is not f times negative 3. This is pronounced f of negative 3. And I know we learned back in grade school of meant multiply, but not for function notation. This is where things get tricky. We're doing function notation. We're saying what's happening, this list of symbols after this is a function. Okay, so I'm telling you this is a function. And I'm telling you this is a function. So you're not determining whether or not it's a function. You know it's a function because I say so. Or I say so here. Okay? So when we look at number 2, it's pretty straightforward as far as questions go, because there's 2 questions. We're going to find g of 5, and then we'll find f of negative 3 in a second. Okay, so the first thing we're finding is g of 5. So remember, we're pronouncing that g of 5. So what does that mean? It means, first of all, that we need to use the g of x equation. And then in the instructions, okay, or in the directions, we have a g of x equation. G of x equals 3x minus 2. And so we're going to use that. G of x equals 3x minus 2. And then we're simply going to substitute 5 where we see an x. Okay, so if g of x is equal to 3x minus 2, then g of 5 is going to be 3x, right? Or 3 times 5 minus 2. So remember, this is not multiplication here. It happens to be multiplication here because the 3 times the x, we happen to be multiplying. So that means we have 3 times 5 is 15, and we have 15 minus 2. 15 minus 2 is 13. Okay, so g of 5 is 13. But here's the deal. We are going to have to make an ordered pair. Okay, because this can totally be expressed as an ordered pair. And remember how ordered pairs work. Remember how ordered pairs work. We have an x, we have a y. We're saying if x, then y. And if that's how an ordered pair works, we can take a look at what just happened, and then we can write it as an ordered pair. Remember, it's if x, then y. It turns out if the x is 5, right, if this x is 5, then what do we get? We get 13. So if x is 5, we get 13. If 5, then 13. Guess what the ordered pair is? 5, 13. That's the ordered pair for that function notation. All right, so it's straightforward. And we do the same thing for the second question. Okay, so that was g of 5. Now we can find f of negative 3. Okay, so you can pretty much run ahead and finish this thing because the rest is kind of straightforward. Okay, so for f of negative 3, we're going to use the f function. Okay, so we're going to use the f of x function. So that's the first thing we're going to do. We're going to use f of x. And f of x is equal to 4x squared minus 6x plus 3. We're going to use that. Okay, but now we're going to do is substitute negative 3. And here we have to be careful with signs. So we know that f of negative 3 is going to be equal to 4 times x squared. Notice the only thing that's changing is the x, minus 6 times x plus 3. So we've used our substitution step, and the rest is order of operations. Okay, so we're going to use order of operations, and then we're home free. Okay, so the order of operations means I have to do exponents first. I have to do negative 3 to the second power. Negative 3 to the second power is positive 9. And then I have minus 6 times minus 3. Minus 6 times minus 3 is plus 18, and then my plus 3 hangs out there. And now that I've done those two steps, I have 4 times 9, which of course is 36. And then 36 plus 18 plus 3, we can just add the rest. So what was that, 36 and 21, 757, right? I hope so, 57. Oh, 57. Well, that was close. So that's what would be if we plug in negative 3 for x. So now we can make an ordered pair. Remember how the ordered pair goes. If then, right? So if x was negative 3, y then is a 57. Cool? Cool. So now we have our ordered pair. We now have function notation. And then we can answer all these questions about stuff. And hopefully we have a better understanding about how some things work. So that is functions and function notation. Thank you very much.